Everyone, a warm welcome to one and all for today's Tech Tuesdays webinar on search intelligence, rank assets based on usage popularity. I'm Vrinda, your host for today's session. And today we have with us Srinivasa Gopal, Principal Customer Success Technologist, as the presenter for the session. Srini here has more than 15 years of experience in handling data governance and privacy and cloud data management solutions. Before we start the session, let's go through some housekeeping tips. The duration of the webinar is 1 hour. That includes a 15 minutes Q&A. You can post your queries in the Q&A box. We'll try and answer them. Dial-in participants are muted for the entire session. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success Portal. You'll be able to download the slide deck from the Success Portal Tech Tuesdays landing page. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. We'll love to get to know from you. The Tech Tuesdays webinars are hosted within Success Portal, which is a micro-learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Srini. Thank you.
Thank you for the introduction. Here is the agenda for today's webinar. We'll go through the use case overview and how to gather the usage statistics from respective sources, loading the content into EDC using REST API framework, how to configure the application in order to use this functionality, demo, and Q&A. Here's a typical data flow with AWS, wherein we can see all the AWS components like S3, Data Lake, Redshift, Data Warehouse, Athena, SQL Database, and various other components interacting with Informatica product stack. We can see the on-prem to cloud migration path here, which is using the data integration framework to migrate the content to cloud. Now we also see the data governance framework, which is Axon, EDC, and IDQ being leveraged here. In this webinar, we'll be focusing on enterprise data catalog, which is essentially scanning all the material from respective sources like Data Lake in S3 or Redshift and Athena, where it is used for data discovery purposes. And since it will be used the data will be used from all the sources by various applications in various patterns. We'll focus on how to rank these assets so that we can see what is the topmost and the least used data assets, specifically focusing on Redshift tables in this particular webinar. Enterprise Data Catalog has a wide variety of features like search and discovery, end-to-end data lineage, AI-powered automated discovery, open framework for custom extensions and integrations, collaboration and social curation to tap into shared data knowledge. The highlighted ones like search and discovery and open framework for custom extensions will be focused on today's webinar. With this can be used for any custom solutions which is not out of the box and uses REST API framework to enhance the application to your respective needs. We have multiple customers requesting for this particular use case. Hence, this might be a good solution for your respective implementations. Of course, it can be customized further as well. There are multiple scanners and with broad range of connectivity here, which will specifically focus on the data-based in this webinar. However, it can be expanded to other sources as needed. We can see like the cloud platforms, Redshift, or all the premium data warehouses, on-prem databases, or even the big data sources. So it can be various sources that can be used for this specific use case to for ranking assets, as long as that information is available with the respective sources which can be extracted. Ranking data assets. From the customer's requirements, here are the needs, where how to rank assets based on usage stats. Like let's say Redshift is used, tables are used. Table A is used 100 times, or table B is used X number of times. How to rank assets based on their usage stats by the respective applications in the source level. What are the top, most, or least used assets in the source? And since the usage varies over time, how to keep the ranking up to date, and how to automate this process to avoid manual overhead using some utilities that can be built to automate the process. Here is a flow for loading the usage stats into EDC. A view can be created in the Redshift database here, and a similar approach can be used for other sources as well. This is for the view is basically to capturing the usage stats from respective system tables. We'll see what are those system tables in next couple of slides. Extract the content of usage like database, schema, table, and number of times it's queried into a file, and it can be pushed into the EDC server using an EDI tool. The utility being built here, it can be used to search for those table assets in EDC. Check if the match found, and if the match is found, capture the respective E tags and update the custom attribute value with the updated usage popularity index. In the EDC, there are some configurations where it can be searched effectively, and those are like some search prefilter configurations having relevant asset type and resource type with sorting enabled. The custom attributes can be created in catalog admin console. Here we can see the usage popularity is created with, of course, there are many other custom attributes. Here, remember to enable filtering, which is very high, and set the search ranking to high. Having the data type as integer. The class assignment, since this specific use case is at a table level, table is selected with specific resource that has been used to capture the stats information. This can be expanded to other levels if we have the respective usage information. Once the custom attribute is created in the catalog admin console, the catalog UI can add the custom attribute so that it can be started. You can start using it, and enable the sorting and filtering. This is a key to do the sorting with ascending or descending order. The next step is to create search prefilter, which we can call the profile prefilter name the way that you call in the functionally, like which is the enterprise data warehouse here with appropriate criteria. So there are various criteria you can set. This is like a kind of grouping all the search criteria into one package. Hence, it's very useful pre-filter settings here. It can be by resource name or used by, who is using by, or modified by, or it can be using any tags that has been used as well. Here in this case, we'll be filtering based on the table and the resource type, which is table and Amazon Redshift. Of course, we can add further pre-filter settings based on the requirement that you have. The profiler pre-filter permissions can be set to all if you want to make this pre-filter to visible to all, or it can be specific to group or users that want to use this functionality. Here, the Redshift tables to capture the usage count, we'll be using the SVB table info, which is a system table, and the STL scan. So we'll be having to create this view in the admin schema. Please feel free to work with your admin team to create this view, which is essentially capturing all the usage statistics like on the table, and along with size and number of times it's queried, unique queries that have been done, and the count of it using NumQS. EDC Swagger, essentially it's a REST API framework, which uses a REST API framework, and Swagger is basically giving you the documentation of what operations are available for custom extensions for your own customized needs. And here's a screenshot. However, there are a lot of other operations that you can go through using Swagger UI, and here the catalog is expanded, and these are the two primary API operations, including other API operations too, which is doing a get to get the object ID and capture the details of the tags, and put is used to update the object back into the application. And you can use this syntax to access your Swagger UI, which has all the REST API operations. Remember to use the default spec. The internal spec is used for internal communications with EDC, with Axon or any other applications which is used, which are subject to change for subsequent releases. So try to use the default spec as much as possible. Here's a utility kind of design or pseudocode on how the overall operation works. The input is essentially the extracted file from view. It contains the database schema, table, and usage popularity index. Here's a sample row, and the process CSV file is a function which extracts the CSV file content and uses the find and update catalog function to execute the search on. Here is the API that we just saw. So it uses this API from the Python script and searches for it, resulted in the JSON, and you can capture the E tag details and update the string with the value which is received from the file for that particular table, and use the request to put the API operation into EDC application to update it. This is recursively executed until all the tables are scanned and updated. The list custom attributes is to find out like all the attributes in the EDC and get the ID of the custom attribute that needs to be updated for usage popularity. Replace existing attribute value is to, as the name suggests, like to update the attribute from old value to the new value. And there are some additional steps taken care where if the usage popularity index is same when it's compared, then the catalog is not updated. Hence, and if the file is empty, it's not being processed as well. So those preliminary steps have been taken care. However, you can extend it to your own requirements since it can be done. This code can be downloadable from GitHub repository. The links will be shared in subsequent slides. The setup of API user access. So this is needed for the Python utility to work. It needs a user account and which has the API privileges and update privileges to update the catalog. So hence, please ensure that you have the required access to make the corresponding calls. And you can download the code here from the GitHub repository for EDC, and feel free to enhance it or customize it to your needs. The package will be published in the Info Marketplace soon. Let's look into the demo now. So we'll start with the first step of creating of view in the Redshift database. You can get help with your Redshift DBA to create this view, which is created in schema admin. We get table scan frequency, which uses system tables to scan SVB table info and joins the table with STL scan, and extracts information of database schema and table and number of times it's queried. It is a distinct query, so it's a unique query being captured to scan, and gets the corresponding information. You can filter down or sort down based on the schema and database based on like the respective requirement that you have. You can always tweak the view that is being created here. Let's use this query to see what is the current usage stats. You can see the usage stats over here with descending order. We can see the table schema and database information with size and number of times it's queried. It's queried 3 times here and 1 time for this table. Let's see with this query here, which if it changes the count, and let me query this one with a different org ID, which is a unique query, and see if there is any reflection of that here. So you can see there is an increase in count on this particular query with increase in count by 1. So this is how you can capture the usage stats. And currently we are updating with the query time. However, you can update the size as well by updating the Python utility to update the size information in the catalog if there is a need around that. So let's look into the code and then the input file here. For the demo purpose, I've already populated this information with appropriate usage counts being extracted. The code here is same as like the design or pseudocode that we went through in the deck, and essentially it goes through the CSV file and updates the custom attribute. Here is the processing of CSV file section, which is recursively processed and updated in the catalog. Here there are debug statements, which is helpful for you to debug, and it uses this API, the get API, to get the JSON file extracted. And the E tag is found, and corresponding facts table, facts information is extracted and updated with the new custom attribute value. So you can see the new attribute value. It is actually compared with the existing value, and then if it's same, it's ignored. Otherwise, if it's not, then only it gets updated by using the request.put function. You can see the put function here, which is updating back to the catalog. So only change that is needed in this utility is if you have SSL enablement, you have to follow the instructions here to update the utility to take the required certificates into consideration. So let's look into the catalog side of things, like where you have to create the attributes first before even running the utility. There is an attribute that is created, which is enabled with the filtering option, and search ranking is set to high. and data type is set to integer. Currently, for this use case, we are setting the class to table, and you can expand it to column level if needed in future. And then the Redshift database specific information is being used here on this particular resource where we have captured the usage stats. So now you can create the custom attribute, and in the catalog UI, so you can use the application configuration. Here the custom attributes are listed with all the tags. The usage popularity here, it is enabled with filtering and sorting. You can uncheck the editing feature here. So since it's being updated by the utility, not through the UI. The search pre-filter settings, you can see there is an enterprise data warehouse enabled, so you can see the criteria using the edit option here. Remember, not all of the users will have this application configuration, so it needs enablement or privileges to be assigned. And the criteria can be seen here. This is the warehouse pre-filter name, and there are various criteria you can set in the resource name, dataset, or sensitive assets tagging. There are various criteria you can search. So it's a combination of search that can be configured into one pre-filter. Here in this case, we'll be setting the pre-filter to table and resource type as Redshift. However, you can use other filters too, like you can do this only for certified assets or highly rated assets, etc., so that you can further filter down on what assets needs to be displayed. The pre-filter permissions is set to visible to all. However, it can be set to visible to only a specific group or user. All right, so let's save this one, and we'll be setting to visible to all for now. And save this search pre-filter. So now we should be able to see the search pre-filter. Here we'll do a star search so that it can display all the tables. So here are the tables for the Redshift database, and you can see the sorting option here with the relevance, name, sensitive assets, and data centers, and you can see the usage popularity being enabled here. So this is how we got the usage popularity by enabling that filtering and sorting option. You can see that you can sort by ascending and descending, and these are the tables. Now let's go back to this utility, and so these are the tables, input file that needs to be updated. Let's kick off this script. We'll run in debug mode so that we can see all the statements in the console. Agree to this policy. I'll use the administrator credentials. However, you can use the user account which has the REST API access. You can see all the debug statements here. Let's allow this to complete. All right, the job has completed successfully. We can see the query that's being used, and the JSON response. So all these are debug statements which you can use to see like how the processing is going on. This utility you can always schedule with a scheduler. Let's look at the catalog now with what has been updated. Sorting, descending. So you can see that is a popularity index updated as per the file here. So I think this is the table which has the highest index. So it is sorted as the topmost used one, which is a fact sales table. And this is the next one that is on the order, team sales territory. Same thing goes with the other tables to fact online sales. Team outage. So this is according to the index that was inputted here. So it is all updated and it can be sorted. So this is for sorting with the topmost one being used to be appearing on top, and you can always do a descending. So to see the least used one. Here in this case, there is no usage on this table. And there is another filter which can be used. Basically, you can use these filters here, like which can be in a range. I can give a range from 1 to 50 to see what are the tables being queried with 50 times here with this range. So you can see the filter down search result here, having the tables listed on top here. The fact IT mission has been queried 42 times. And same thing goes with this one with 32. In currencies on 23. So this is how you can filter down, and this can be increased to see like further filter down on like 2000 times. Let's see, 100 to 2000. So this again, like you can see like what is above 100 and below 2000 times being queried. And it can be sorted as well. And you can go in detail of the most queried ones, and as an analyst and or steward, you can analyze further by going into depth of this table and find the usage information on why it's being queried and where it's coming from a lineage point of view. This can be analyzed further. In this case, this table doesn't have a dependency of upstream and downstream here with these many columns. Hence, if there is, let's say, if there is no dependency with other objects, and it's a least used table, this can be considered for decommissioning, or if it's the most used one, you can see like how best it can be used to improve the performance by improving the quality score and etc. So there are multiple usage of doing this usage popularity with topmost search, and take further actions based on the governance policies and principles. The Swagger UI that has been used here can be used to know what are the catalog API operations available. This can be used for various use cases that you have, and in the present use case that we discussed, it is primarily for get and put operations, and it uses the custom attribute listing as well. The reference section can be used to see the how to use the REST APIs with examples Python code listed. You can download that and start exploring with your own use cases. This is how you can use EDC with your own custom extensions and REST API framework. Thank you all for attending this webinar.
Everyone, if you have any queries regarding the session, please post them in the Q&A box. We'll try and answer them. Over to you, Srini.
Sure. Yeah, one thing I'd like to add is that the link that is provided in for the GitHub repository, it's community based, so you can always subscribe, and if you are planning to build your own code, you can always add your own use cases and corresponding code and push the code to that same repository. So it's kind of a community, kind of EDC community GitHub repository. So please feel free to use that for all your custom extensions. Yeah. And the references section has something called EDC REST API starter guide that can be this one. So there is an EDC REST API starter guide that has been submitted that you should see in the as a white paper in the Informatica Network portal. It has some like all the EDC REST API operations along with sample code, so that you can, if you are new to the REST API, it's definitely a value one, like which has some examples also that you can try. So it has Python and Java examples too. So whichever you are comfortable, that you can use that and build it. In this particular webinar, I used PyCharm, but you can use Microsoft VSS or any other Eclipse platform or anything like that you are comfortable with the IDE. And for automation, you can use any scheduler to kick off the job to run the script at regular interval. Yeah. Any questions so far?
Thank you, Srini. Before we jump into the questions, just wanted to call out that the session is being recorded and will be available in the Informatica Support YouTube channel and the Success Portal Tech Tuesdays page, where you will find all Tech Tuesdays webinars, including the slide text. Also, right after this webinar, there is a survey. You can go over it and let us know your thoughts about this session. And if you have any suggestions for future sessions, you can also let us know through that. We would love to get to know from you. Yeah, please post your questions. If you have any doubts, just post them in the Q&A box. Srini is here to answer them. Srini, let's wait for some more time before we can end the session.
Sure. Yeah, thank you. One more thing I'd like to add to everyone on the webinar, we had questions on, although this was a Redshift case study for updating usage popularity, I had multiple customers asking for the similar function for other sources like Hadoop, Hive sources, or even for Snowflake and other sources. So as long as the usage stats is published and it's as part of the audit table, it can be captured and definitely it can be updated. Definitely reach out to your respective sources if there is any. For example, if it's an Hadoop lake, you can check if that can be available through the Atlas in case of Cloudera, or in case of AWS EMR, there should be similar system tables provided that can be extracted into this. And another use case is like, can we capture SQL queries? This is the count along with the count, right? Definitely it can be captured. It needs some more enhancement to capture that and update the custom attribute with the same utility can use and enhance it accordingly. There's a question from.
We have one question.
Yeah.
Please go ahead.
I saw that. Yeah, no problem. Do you have an option to identify and notify alerting mechanism if there is any change in assets? Yes, Rajan, actually, there is a notification feature that you can use a follow option where any changes to the assets, you'll get notified. And there is a change summary also if you enable the track source changes while you are scanning, that actually captures the changes that occurred also. So both can be enabled. That's out of the box feature, so there's no customization on that. So one more question: can we fetch monthly stats when we use MDM resources for change in base objects and child entities? So I believe the monthly stats is the metadata change, I believe. So in that case, again, you can use the follow option where any change, and when you refresh the resource or a scheduled resource, when it gets refreshed with the new content, the change summary is going to capture that all the stats. So you can download that as well. Like each change, it's downloadable at a resource level, so you can definitely download that. It's available in majority of the resources, so not only MDM. So like a kind of Snowflake or any data lake like S3 or ADLS, this follow option is available. And also you need to enable the track source changes on the resource level, so that the change summary gets enabled, right? So, Rajan, I hope that answers your question. Yeah, so especially the use case wise, we can definitely expand it to other sources. As long as the stats is available, definitely it can be expanded. Okay, so there's one more question from Rajan. What would be the best practice and time interval to set refresh pattern for resource? Okay, so this is a good question. So the best practice is to have, when the source refreshes, like let's say the source is Snowflake and it refreshes daily, it's best to follow up with a refresh on EDC as well, so that it reflects the latest changes. So definitely the source refresh schedule can be set as a dependency to EDC resource schedule. Thank you, Rajan, for the feedback.
Thank you, Srini. Let's wait for one more minute. If you do not have any questions, then we'll wind this up.
Thank you.
Yeah, looks like we have answered most of the questions. Thanks everyone for joining. Thank you, Srini and Harry, for spending some time for the great session. Thanks, Srini, especially for the great presentation. Thanks a lot. See you on our next Tech Tuesdays. Bye.
Thank you. Bye.